Hi, everyone. Welcome to the Deep Dive series. Today, we're going to deep dive on developing for Azure Sphere over-the-air updates. If this is your first time being at a deep dive, welcome. We're excited to have you. This is a technical event series where we deep dive into a new product or feature or a new solution or a different scenario. And it's going to be different every single time. So we're excited to have you. And what's great about these deep dives is that we do have the live Q&A. So if you're joining us live, feel free to ask us questions and chat on the right side. We'll be there, Mike and myself, answering your questions throughout this whole training video. My name is Pamela Cortez. I'm going to be playing the role of the host today. I am a senior PM and also advocate on the Azure IoT product team. Along with hosting the Deep Dive series, I do a lot of training videos where I train developers on how to work with devices and how to get started with Azure IoT. Today, I'm going to be joined with Mike Hall, who is our main speaker. Mike Hall is a principal software engineer on the Azure Sphere team. And this is actually, Mike, I think we've done a couple of these videos on IoT show together. So I'm excited to be on screen with you again. Do you want to talk about a little bit what you do on the Azure Sphere team?
Yeah, it's great to be back. Last time we talked, we were talking about this guy, which is an Azure-based real-time self-balancing robot. So I work in the Azure Sphere team on a team that focuses on hardware and demos, the devices and demos team. So building out things like the robot that show the capabilities of Azure Sphere.
Yes, and I'm still waiting for that robot in the mail, Mike. I thought you were going to send me. I thought you were going to send me this robot in the mail.
So I'll check on progress in a minute.
Yeah, we'll do many of these videos, and I'll keep asking you. But if Mike made a mention of a past video that we did, which was that self-balancing robot, and then we also had a previous deep dive about developing for Azure Sphere, and that was with Richard Taylor, and he did a phenomenal job doing a technical walkthrough of when you get the kit, Azure Sphere kit, how do you claim the device, how do you connect it to Wi-Fi, and then what are the samples you can do. And so he did a phenomenal job. We do have that link on the screen right now if you want to check it out after this deep dive. So for today, we're going to be all about Azure Sphere over-the-air updates. If you're new to Azure Sphere, just to give a high level, and then Mike's going to deep dive a little bit more on what Azure Sphere is. Azure Sphere offers a secure platform for developers to build high-level applications to run real-time capable apps. And so we're going to do a technical walkthrough of those high valuable capabilities while deploying apps for Azure Sphere with over-the-air updates. Mike here is going to be talking about that, and he's going to give us a cool demo. So as I mentioned, I was just doing a high level, but Mike, do you want to give a little bit more information for folks who, maybe this is the first time they heard of Azure Sphere before we jump in?
Sure, of course. So Azure Sphere is a secure platform for building internet-connected devices. In effect, you can think of Azure Sphere as having three parts to it. The first of which is an Azure Sphere chip, which is secure, connected, and you can think of this as being a crossover microcontroller. By crossover, I mean that it contains a high-level A7 core, as well as real-time capable M4 cores. In fact, the robot that we saw just a few seconds ago is running a high-level app on the A7 to connect to the internet and push telemetry, and all of the real-time code to balance the robot and read the sensors, control the motors, is running on one of those real-time capable M4 cores. So the second part is the Azure Sphere operating system, which is a custom Linux-based operating system that connects to the Azure Sphere security service, which is the third part. And the Azure Sphere security service is a cloud-based service that communicates with Azure Sphere devices to enable maintenance, update, and control.
Wonderful. Thanks, Mike, for that refresher on what is Azure Sphere for folks. Today, we really are going to focus on those over-the-air updates and how to do that with Azure Sphere. And before we get to that, let's maybe talk about why over-the-air updates are so valuable. The first thing that comes in my mind with working devices is if there's a security vulnerability, you need to be able to quickly send a fix for that particular issue. Could you maybe elaborate or give more information about why over-the-air updates is so valuable, especially with Azure Sphere and devices in general?
Sure, of course. So I think there are a number of reasons why over-the-air updates are valuable. The first of which is if I'm a device maker, a builder, then what I may want to do is roll out new features or updates to features to my device over time. And obviously, sending out an engineer to manually update thousands or tens of thousands of devices is very time consuming and expensive. So having the ability to dynamically update your application and to push out new features on demand is very valuable, right? The next is to potentially fix usability issues in your applications. The devices, Azure Sphere devices, are connected to the internet, so you can push telemetry, maybe kind of looking at how your device is being used, how features are being used. And it may well be that certain features are only partially used. Well, why is that? You may have an issue that needs to be fixed inside of one of your features, and therefore, again, you can push out an update to your application. And by pushing out an update to your application, I mean both an application that's running on the A7 as well as applications that are running on the M4. So for the robot, we can update some of that real-time code or some of the code that is connecting to the internet. And as you mentioned, having updates that kind of fix vulnerabilities. As an application developer, maybe I found a vulnerability in my application, so I can fix and update that. But also, the underlying Azure Sphere operating system is updated by Microsoft. So as there are updates to the OS, we can push those out to your devices as well, which really allows you as the device maker to kind of focus on your applications and your application functionality rather than having to worry about the operating system.
That makes sense. That makes sense, Mike. And I think even when we were doing that IoT show episode, the self-balancing robot was also using Azure RTOS too. So if you're interested in learning more about Azure RTOS with Azure Sphere and that extra layer of security and being able to do over-the-air updates, we covered it just a little bit in those episodes, but feel free to check that out. The link will be in chat and we'll put it in the description. So we talked about why, it's important to do over-the-air updates. But when we think about Azure Sphere, how do these updates work?
Well, you mentioned Richard did a show recently with you to talk about the developer experience. And as part of that, he kind of briefly introduced products and deployment groups and various other concepts. So I've put together a short presentation which will go into that in slightly more detail so that we can then get into not only showing live updates to a device, but also looking at the code that you would write as a developer to defer updates to your device. So let's go and take a look at the presentation. Okay, so here's my device. This is an Azure Sphere development board, and every board has a unique ID. So here's the unique ID for the device that we'll be using in the demo in a few minutes. And so for this device, you can obviously think about building some kind of device, whether it's the balancing robot or, a washing machine or whatever it's going to be. So we'll call this device A. So as an Azure Sphere developer, you start off by creating a tenant. And a tenant is, in effect, a container for all of your devices. You mentioned claiming. So all of your devices get claimed into a tenant. So in this case, we have a tenant called Contoso, and device A has been claimed into that tenant. If I'm a relatively large business, potentially I have more than one tenant and maybe different product groups within my company working on different devices. Maybe it's more likely, however, that inside of my own company, I have a tenant called Contoso, and I'm building multiple products. For example, a washing machine or a pick and place robot, a self-balancing robot perhaps, and dot 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 product X. So there is a notion of inside a tenant creating a product, and then within that product, you have various device groups, and your product is in effect associated. By product, I mean your device is associated with a device group and also a product. So by default, there are a number of device groups that get created. For example, development has over-the-air updates disabled. So if I move my device into the development device group, that means that I can either use Visual Studio or Visual Studio Code to write code and then deploy it to my device, and it won't get overwritten by an over-the-air update. However, for field test, which is the device group that I'll be using for today's demo, over-the-air updates are enabled. So that means that I can push out updates to my application, and my device will then update with that new version of the application. And you can see that I've got production, field test, OS evaluation, production, OS evaluation. So that by default, there are 5 device groups that are created for you. And on the right-hand side here, you can see device group X. You have the ability to create your own device groups as well. So, why would you do that? Well, the first reason may be that you want to have development and deployment rings. Maybe you have a daily build, an internal build, a weekly build, a monthly build, or whatever it's going to be. But you can also think about building out these device groups as regions. Maybe you have a North region and a South region, or an Asia, Europe, US, or however you want to do it, which gives you a huge amount of flexibility in terms of how often and how you are pushing out updates to various groups of devices. So in our example here, you can see the production device group has way more devices in it than, say, development or field test. This could be tens of thousands of devices in here. So in terms of deployment, I can update my application, and through a simple command, which we'll see, a command line command, which we'll see in a few seconds, I can push out an update to every single one of the devices in that selected device group. And so that's how updates work.
Okay, thanks, Mike, for that deep dive into how the over-the-air updates work. You have washer machine, you also have a pick and place machine as samples, but let's say I have a washer machine, it's a connected washer machine, and it's actually washing my clothes at this moment, and we need to do an over-the-air update. If it's washing my clothes at this moment and you're pushing this update, I can imagine the machine's going to go ahead and stop. It needs to take that update, and your clothes are soaking wet. How do you prevent that? What is the support that Azure Sphere team has done to help with those situations? Because you don't always want to update a device right away, even if it's a security vulnerability. There's still things like the devices that are in action that we need to consider.
Right, you're absolutely right. For our now infamous self-balancing robot, the last thing you want to do is take an update while it's balancing.
I know.
It's not in a very safe position there, right? So Azure Sphere supports this notion of what's called deferred update. So as an application developer, I can write my code in such a way that I get notified that there is an update available, and I get to make a decision about whether I'm going to take it now or take it later. So the robot, for example, will push off or defer an update until it's in a safe position. Safe meaning laying down. So when I lay the robot down, it's in a safe position, it can take the updates. But I actually have a demonstration here to show you what happens to a device when it's in an unsafe mode, for example, right? So here's my device. This is an Azure Sphere development board on the right, connected to a 320 by 240 SPI connected display. And this is running an application. You can see in the top corner, app 1, and the application is currently idle. It's in the scenario that you painted, it is not currently washing your clothes, right? And it's showing some kind of image or text underneath. However, by pushing button A on the development board, light comes on the board, and the text now changes to show the word busy. So this device is now like the balancing robot standing up, or in the case of the washing machine, it's in the spin cycle or something, right? Okay, so now let's push an update to this device that will get the application on the device to update. So I've got an Azure Sphere developer command prompt open here. What I'm going to do is just type a command. This is running application 1 currently. So I'm going to type a command. You can see that came up quite quickly. I'll explain what this command means. This says Azure Sphere, which is the command line interface, device group, which we now know what that means, deployment, I'm pushing out something to a device, create, -pn product name. Remember that we had our washer and our pick and place robot. Well, I created a product called IoT Show, and we have our device group name field test, and then -p for package, image package, deferred update app2.image package. So I'm just going to hit return here. And what this will do is tell the Azure Sphere security service that we want to push out an over-the-air update to devices that are in that field test group. Now notice that I've got a warning, an image with the same ID has already been uploaded. Yes, that's correct. I've already uploaded this app in the past. I've obviously made sure the demo works. Right?
Yeah.
Okay, so now what I'm going to do is type a command that says Azure Sphere device restart. I could also push the reset button on the device, which will restart the device. Now, so the question is, why am I restarting the device? The reason why I'm restarting the device is by default, these over-the-air updates, devices are checking for over-the-air updates, either when they restart, which we've just done, or every 24 hours. And this device has been running for some amount of time. So, that 24 hours could have been up in 1 minute or 23 hours from now, right? So if we have a look at what this device is currently doing, the device is running, the busy light is on, the busy text is currently flashing, but this application that has been deployed to the device doesn't have any support for checking for over-the-air updates. So what's going to happen is when it gets that update notification, in effect, that application, in fact, you can see busy has stopped flashing, right?
Yeah.
Which means that the app is no longer running. And oh, look, the device is restarting right in the middle of washing your clothes. And now we've come into the updated application. This is application 2 now, right? And this is still showing busy, right? And the reason why it's showing busy is because in a second, we'll see what happens in an application that the developer has written the code to correctly handle over-the-air update notification. Right. So do we just want to jump in and take a look at that scenario now?
Yes. I was just going to ask you, I would love, as a developer, love to just dig into the code. So how we can leverage that feature. Definitely would love to see that, Mike. Let's jump right into it.
Right. So let's go take a look at the code. And then once we understand what the code is doing, we can come back to the application running on the device and push another update to it and see how that update is then handled by this device that now supports over-the-air update notification.
Okay, great. I don't want my clothes wet from the washing machine. So show us how to fix that.
All right. So this is Visual Studio 2019. As a developer, application developer for Azure Sphere, I can write my code in Visual Studio or Visual Studio Code. I can develop on Windows or Linux. In this case, I'm using Windows and Visual Studio 2019. So to write the application, there are a few things that you need to understand. The first of which is we've talked about security. Every Azure Sphere application is built and has one of these files called appmanifest.json. And in effect, this defines the capabilities that my device, this application, is going to use. So for example, this device uses mutable storage to store the state of the busy or idle state of the device between reboots. So I can expand that out, and you can see that in this case, I'm requesting 16 KB of storage. If I didn't have this in there, and my application tried to write to storage, then that would fail because I don't have that capability. In the same way that I'm using things like GPIOs to capture that A button press or to turn on that LED on the device. But to support over-the-air notifications, I need two capabilities enabled for my application. The first of which is system event notifications, so I can get those notifications that there's an update, and then software update deferral, which gives me the ability to then say, no, hang on, I want to push off that update, or no, it's okay, I'll take that update, right? So the first step is to modify your application manifest to put in these two capabilities. Right, now let's go over to the application. So this application is based on, you've already mentioned, some Azure Sphere samples. GitHub Azure Sphere samples contain a number of samples, some very simple, like blinking an LED, others more advanced, like handling over-the-air updates. So this application is based on that over-the-air update sample. I've extended it because we now have this display and some additional capabilities, but it's based on that sample. So what does this application do? Well, we initialize the display. We create a handle for our button. We create the LEDs for showing state on the device. And then we create timers. We'll come back to the timers in a second. We also, from that mutable storage, local storage, get the previous busy or idle state and then update the LEDs appropriately. And then the main loop of our application is then basically just calling this event loop run and then looping. We'll come back to what event loop run means in just a second. Right. So if that while loop gets terminated, for example, by an over-the-air update, then we change the icon on the screen, clean up, and let the application exit. So what happens in create timers? We create an event loop, which is driven off of that main loop. We also set up a couple of timers in here for reading the button state and for updating or refreshing the display. And then here's the important part. We call a function which is called sysevent register for event notifications. The event notification that we're interested in is sysevent update ready for install. And we provide a pointer to our update callback function, which you can see is just below here. Okay, so what happens in the update callback function? So there are a couple of things that are happening. The interesting part for an application developer is the status, which we'll come to in a second. But you can also determine by calling sysevent info get update data whether this update is for the operating system or for an application that's running on the device. That's important because you can defer operating system updates for up to a day, but for an application, you can defer updates for nearly a week. So if it's an operating system update, you need to take that within 24 hours, but you've got a full week in order to defer updates to an application. Okay, so let's have a switch statement based on that status, and the status is really telling us what's happening in terms of the update. So what we're saying here is that if there is notification that there is an update pending, we're checking a flag to find out whether our device is busy or idle. If it's not busy, then in effect we don't do anything. We just say, okay, we'll let the update flow through. Otherwise, if we are busy, then we call this function sysevent defer event, and we pass in a value for the number of minutes that we want to defer. Obviously, in your case, when you're talking about the washing machine, you probably know that the spin cycle is going to be complete in 20 minutes. So maybe you defer the update for 30 minutes. And that doesn't mean that the update will just be applied in 30 minutes. It means you get another notification and you can check to find out whether now's a good time to take it or not. And then sysevent update status final is a final notification that you have about 10 seconds before your application gets shut down. Okay, in our button, yeah, was there a question?
Oh, no, go ahead. I was just I was going to run through making sure I got all the information that you're sharing in the code.
Okay, great. So the button A handler is simply just flipping the value of device busy from true to false or false to true. And also, this is kind of interesting, is if the device is not busy and we have an update deferred, then we make a call to sysevent resume event. In effect, our device has gone idle, right? It's no longer busy. So if somebody pushes the button on our board while it's deferring an update, this call simply says, I'm ready to resume the update that was deferred on this device. And that's about it from the code. So there's really not a whole lot that you need to do. Set up a timer, set up a callback handler, and make a decision about whether you're taking an update or not.
Yeah, so that's the code part with main, and then also being able to enable the software update deferral and the system event notifications, right, in that app manifest JSON. So it's two areas that you need to update.
Yes.
Okay.
Yes.
And as a developer, is there any other thing that you want us to take away from this? Because you did a phenomenal job going through the example code. That sounds like it's hosted on GitHub, and it's really straightforward, those two files and what you need to do. Is there anything else you would like us to take away from, or best practices, or some insights based on your experience?
Yeah. Well, first of all, I think we should actually see it in action.
Yes.
All right.
Yes. Before we even get there, yes. Let's see if it actually worked. Here I am already saying that it's working, it's good to go, but yes, let's see it in action.
Okay, so here's app 2. And app 2 has all that code in it that we've just seen, right? So this will handle over-the-air updates. And you'll notice from the flashing text that the device is still busy. It's balancing, it's washing your clothes, it's doing its task, right? So what I'm going to do now is come back to our command prompt, and I'm going to push out an updated version of application 1. So the command is identical: Azure Sphere device group deployment create product name IoT show device group name field test, and then the package, the image package, is deferred update app1.image package. So I'm going to push this out, which will create a new deployment from the Azure Sphere security service to this device, or to all devices within the field test group for this product. And again, we'll get the same warning that we got before. We've already pushed this. It's already there. I don't need to update it, right? And then I'll restart the device, same as we did before. And we should then see the device restart. And obviously, again, we're restarting because update checks happen on device start or every 24 hours, right? So what's going to happen now? The device is flashing busy. If you remember last time we updated the application, we just saw busy freeze because the update was just taken, and in effect, the application was shut down underneath us, right? So what we're going to see now is we'll get that notification. There's an update. See that icon appear up in the top right corner?
Yes.
That says update with a little clock that says I've got an update, but I'm busy. So I'm going to defer that update. So now if I push button A on the device, that'll put it into an idle state. You'll notice the clock has disappeared. But the icon is now saying, okay, I'm going to take that update, right? So that means, and now we've got the hourglass, which says, okay, we're getting ready to restart and update to that new application, right? So that's in effect, I'm pushing the button there to say I'm forcing it into an idle state. But in the case of the washing machine, it could be that the wash cycle is completed, or it could be that in the case of our robot, that the robot is laying down, or in place robot, or industrial control machine, or something. Maybe there's a production run, and you need time to schedule the update of the software that's running on that device. So there we are. We're back into the updated version of application 1, but we had full control over that update experience on the device.
So it's going to constantly work. If you send another update, it's going to go ahead and make sure it's not running at that time. And then when it's done and ready to take that update, the update will go ahead and go on the device.
Yes.
Yep.
That's
Yep.
correct.
Well, I love that I assumed that the demo was going to work when we had the code, just because I've known you for a while now, and I haven't seen your demos not work. So this is great, Mike. Love to see that in action. And then to go back to my question before, as a developer, is there any extra insights you would like to share with us on how to get started? More of when you do over-the-air updates, what do you need to think about?
Yes. So I think there are a few things to think about. The first of which is that updates for your device are really critical to building secure products. From the update perspective, we can push updates to the operating system, and you, as the device maker, can update your application either by adding additional functionality or by fixing a problem within your code. Deferred updates, what we've just seen in that last demo, are really important to allow you to build safe products. In the case of the washing machine, if it shut down and restarted halfway through a wash cycle, well, it's not the end of the world. You could potentially manually just kind of finish off that process. But in the case of an industrial control or automation machine or a self-balancing robot, it's really bad if you try and update it in the middle of, some kind of critical task.
Yeah.
One thing I mentioned is that OS updates can be deferred up to 24 hours, and app updates can be deferred for 167 hours or just about a week. So I think kind of in closing from my side, a couple of things to mention would be Azure Sphere is available as a generally released product and is available for you to build your products. It's highly secure with us servicing the OS and you obviously servicing your applications. From a developer perspective, you can develop on Windows or Linux in Visual Studio or Visual Studio Code. And there's a huge amount of resources out there in terms of samples and documentation to allow you to get started.
Love it, Mike. Thank you so much for giving us that overview. I know it's a question we get a lot, is how you do over-the-air updates. So I'm glad we finally have a video on this to teach people a little bit more on how to get started. And we actually went through the code for folks and showed what are all the necessary steps for them. So thank you so much, Mike. Maybe we'll go ahead and close on resources. If you're just getting started with Azure IoT or Azure Sphere, check out Microsoft Learn. We have a bunch of hands-on labs to take, some tutorials, and so we really recommend, if you're just starting off, to head off to Microsoft Learn. Next, if you're interested in watching more videos like this with the Deep Dive series or smaller announcement videos, check out IoT Show and the Deep Dives on our Microsoft IoT Developer channel. And if you're interested in talking to us or other community members or seeing the slides to this presentation, go to IoT Tech Community. That's when we post announcements, where communities share their projects, and a great way to chat with the team. And if you have technical questions, go to Microsoft Q&A. We're on Stack Overflow and other places as well. But if you go to Microsoft Q&A, it's a great way to get connection with our engineers and ask your technical questions in this location. And these are the Azure Sphere resources where you can learn more. We have a link to the homepage. We also have where to go to get started. So if you want to have a tutorial or get some more documentation, we do have that link on the screen as well. And then if you really want a deep dive of what Mike showed today with the deferred APIs with Azure Sphere, here is the direct link on how to do over-the-air updates and deferrals. And we're going to be providing all of these links in the video description as well. So thank you so much, Mike, for joining. Thank you, everyone, for asking your questions, and all the people viewing on demand. We're excited that you're here. And if you have any feedback or suggestions for topics, feel free to ping me on Twitter and hashtag with Deep Dive. So thank you so much, and I hope everyone has a great day. Bye.